Hello, students. Today we will be talking about Chapter 1. But before I start covering Chapter 1, I would like to do some housekeeping. I'm pretty sure you might have gone to the Canvas course and looked over the course. You were asked to do the orientation unit, which consists of start here, contact information, send me your electronic signature, email introduction assignment, and post in the discussion on student introduction. And you might have looked over instructor information and the course syllabus. So those were the first couple of days activities. And you might have also noticed at the very top the link to the course in MindTap, which is called MindTap COSC 1436. And then after finishing up the orientation unit, we move on to unit number 1, which is the topic of this lecture. In unit 1, I'm pretty much covering the chapter 1 of the textbook, right? And so when you go to the module section of your course in Canvas, you will see unit 1, overview of computers and programming languages. In that unit, you start off with, obviously I'm going to post this lecture there, and then after that the links to various resources follows. You have chapter 1 outline PDF for you to go over, and then unit 1 read, which takes you to MindTap and gives you links to various pages of chapter 1, which I would like you to read thoroughly. Take a couple of days to read those pages thoroughly. And then after that, there's a series of videos that you can watch. One of the videos is a programming example on how to design an algorithm. That is one of the examples in the textbook, actually. It's a video about an example in the textbook. And then we have we finish off the chapter by doing some exercises. I have two parts to it. One part is in MindTap. The other one is manual. You have to fill out or do it on paper, and send it to me electronically as an attachment. And then there's a discussion post on history of computing, and then you take a quiz, and there's chapter review and chapter reinforce, and we conclude the unit with a chapter 1 exam, which you take inside Canvas. So that is, in a nutshell, how we're going to do the start of the semester, as well as finish unit 1 in the process. I expect the unit 1 to be completed pretty soon. I will be putting due dates on each of those activities in MindTap as well as the activities on Canvas. So keep an eye on all the deadlines and due dates in both Canvas and MindTap. MindTap has its own due dates, and inside Canvas I have some due dates. Now remember, you got to check both the calendars, the MindTap calendar as well as the Canvas calendar, because MindTap activities don't show up in the Canvas calendar. And also vice versa, the Canvas activities and due dates don't show up in the MindTap calendar. So you got to check both calendars, all right, for due dates. Right now, I'm in the process of setting up the due dates. So try to finish as many activities as possible. Go as fast as you can. But in a couple of days, I will have the deadlines and due dates available for all the activities for at least the unit 1 and 2 done. Okay, so coming back to the chapter 1 lecture, I'm going to breeze through this chapter lecture really quick because a lot of information is pretty fundamental and you all are probably aware of all that information. So there is no point in going into details of this because all of you are computer literate and know the basics of what is input and output devices, input devices, and so on and so forth. So I'm not going to go into the details of it. I'm going to concentrate on things that are probably new to you, right? So let's go ahead and start with the objectives of the chapter. The chapter has several objectives. It will teach you about different types of computers, learn about computer hardware and software and different components of the computer system, learn about how computers are programmed using computer languages, and the evolution of computer programming languages. It talks about high level language and low level language and the different things you need in order to write programs using a particular language and then prepare that program to be executed on the computer and make the computer do what you want it to do. Remember, computer is a dumb device, right? It is as smart as the person using it. So, and the objective is to utilize the computer and help us solve the problems that we want the computer to solve. Computer has advantages over humans because they are faster when they are programmed to do certain tasks. And that's why we use computer languages to write programs and make the computer do what we want them to do. So we're going to also explore specifically one programming language, C++. Again, we chose C++ as a language of choice in this course because it's a mature language. It has a lot of usage and deployment throughout the world, and a lot of applications, programs have been created with it. There's a lot of support for it, and a lot of universities teach C++ in their computer science courses. Now, it doesn't mean that once you learn C++, you're stuck with C++. You cannot move to other languages. That's not the case. We're using C++ programming language to teach you programming. Now, those concepts that you learn about programming can be translated to other languages such as Java, Python, C#, and a plethora of languages that are available. So the objective is to learn programming, learn problem solving using a language such as C++. But the emphasis is on problem solving, students. That's what you're going to be learning. You're going to intellectually improve your capabilities in the realm of problem solving, which is the basis of everything. Problem solving and how to plan, develop a solution, and implement that solution. Now, the vehicle is obviously C++, and you have to learn the syntax of C++ in order to solve the problems using this particular language. But the objective is to learn programming or problem solving and using computers to solve problems. Always remember that. So that's why I do as many programs as possible. I will be assigning you some problems and exercises throughout the course, but don't limit yourself to that. You can solve as many problems. The more problems you solve, the more code you write, the better you're going to be. Just like mathematics. The more problems you solve, the better you're going to be in mathematics. By doing just an example, you're not going to be an expert in mathematics. So here also, by doing examples and seeing code written by somebody else is not going to make you a programmer. You got to write code yourself from scratch. You got to look at the problem and come up with a solution, write an algorithm, write the instructions, and compile it and run it, and try to solve the problem. And that's how you're going to become an expert. Now, you cannot become expert in a month or two. It takes sustained effort over a long period of time to become an expert programmer. So you are pretty much on that journey. This is the first step of that journey of you becoming a programmer. But I can understand if you're taking this class for requirement in your major, such as mathematics, physics, engineering, and stuff. But learning programming is always useful, beneficial, and many times necessary. So here it is. We're going to learn C++. We're going to learn about algorithms and how we can solve problems. There's problem solving techniques out there that are best practices we can use and utilize to solve some problems. But you can also come up with your own problem solving techniques. There are two ways to write code these days. using computer languages. One is called the structured design, which is the old way of doing things, which hardly anybody is doing right now. Hardly anybody is doing it. We still use structured design to learn programming, to begin learning programming, and then move to object-oriented design, which is the current practice in programming. So there are different versions of C++. Okay, we're going to be using the standard C++. Going through, as you can see here, without software, computer is pretty useless. If you don't have software, you cannot even add two numbers. So that's where the programs come into play. And to write programs, you need to learn programming languages. So in the next couple of slides, I'm going to be showing you the history of computers, but I won't be talking or explaining about it. But know that the computers of history goes back to thousands of years. People have been using devices that help them compute and calculate things, right? So we are now, we have supercomputers, mainframe computers, workstations, laptops, and we even have cell phones as computers these days. So we have computers coming in different shapes and sizes and power and capabilities. So, but every computer has two parts to it, hardware and software. You all know what that is, right? And hardware consists of CPU, main memory, which is the primary storage, secondary storage such as hard drive and USB drives, external drives, and so on and so forth, and input-output devices. So you all know that the central processing unit is the brain of the computer. It is probably the most expensive piece of hardware, but the gamers out there might disagree with that because their graphics card is much more expensive than some of the CPUs out there. Okay, so here is a little graphic on the central processing unit of the main memory, which is inside your chassis of the computer. The primary storage is actually a random access memory, which is directly connected to CPU on the motherboard. And the main memory is like the kitchen table where you bring in things and then you do stuff with them and then execute, right? And after that, the contents of the main memory are lost once you either turn off the program or turn off the computer. So I'm not going to go into the details of it, but you still need to understand what is memory and what does it consist of. Memory consists of cells, and each cell is addressed uniquely, right? And then that's what we're going to use in programming. We target the memory cells, which has unique addresses. And this is at the low level, though. In programming 3 or 4, the third part of the programming and the fourth part of the programming, you'll be learning how to work with memory directly. But now in programming 1 and 2, you don't do that. You let the computer do that work for you. Okay, that's why we use high-level programming language such as C++ to write programs. So secondary storages examples are hard drive, flash drive, and the CD-ROMs. Input-output devices, you already know that, so I'm going to skip that part. And the different kinds of software, basically the programs or the software that resides on the computer falls into two categories: the operating system and the application software. The operating system is pre-installed on the computer. Without the operating system, you can't even start the computer. It won't even start. And without application software, you cannot perform any tasks. So those two pieces of software needs to be there. And as software engineers or software programmers or computer programmers write both the operating systems or the system software and the application software. It depends on your expertise. Later on in your career as a programmer, you can specialize in either operating systems programming or systems programming or application programming. Most programmers work as application programmers or application developers. As I've read through your postings, there are several of you who want to write code and develop games and game programming. Let me tell you, it's the hardest thing to do. Writing a piece of business software is in my opinion, is easier than writing a really good computer game. Computer gaming industry hires the best programmers that are out there and pay them pretty good bucks. So if you want to be a game programmer, then you should be one of the best programs that are out there, highly talented, so you can develop good games. So keep that in mind as you're going through the course. Pay attention if you're planning to be a game programmer, game developer of some sort. Okay. Remember, it's all about ideas and problem solving. People have become millionaires and billionaires even by solving problems using software. Uber, take for example. These all Google, Uber, Facebook, Instagram. These guys develop software, and using that piece of software, they became millionaires and billionaires. So what does the software do? It solves the problem. So if you can come up with a problem and you can solve it using computer languages and computer program, you can be the next billionaire. So a computer is a digital device. It works with binary digits, and a collection of binary digits is called a byte or a kilobyte and megabyte and terabyte and so on and so forth. I'm not going to go into that. You all are familiar with that. And there's a chart that shows you the units of the binary units, right? Different units. They're a coding scheme because obviously binary is just ones and zeros, and those combination of ones and zeros can be coded into meaningful information inside the computer, and that's what the computer engineers do. They come up with ideas to code information inside the computer using binary digits. And then that is a big field also. As computer engineers, you need to understand and be able to do that also. It's not just about writing code. It's about encoding information. That is also one of your tasks. So back in the day, people used to write programs in machine languages using ones and zeros. Believe it or not, I did that when I took one of the programming classes in my engineering program. We had a machine language. It was a big headache. So we'll be typing ones and zeros using two buttons. And one was a green button and one was a red button. So green was 1 and red was 0. So you would be typing combinations of ones and zeros. Thank God we don't have that. We have a keyboard now, so which has everything on it. So but you know what? The good news is that you will be learning machine language later on in your career here with us. And hopefully I'll be your instructor when you take that machine language class. There's quite a bit of new vocabulary that you need to get used to. Things like mnemonics, assembler, syntax, things of that nature, and the details of the language and the vocabulary of C++ or computer programming. So slowly but surely you will learn that vocabulary. But remember, don't dismiss it as just vocabulary. Hey, this is just something I don't need to remember. No, you need to remember. You should study. You should memorize and learn and understand and know the vocabulary. That vocabulary should be part of your vocabulary when you're communicating with me or with with your classmates or with other professionals. So remember that. So I'm gonna go further on programming languages after the assembly language programming. High-level languages were developed, such as BASIC, Fortran, COBOL, C, C++, Java, and now Python. And these languages needs a compiler so that these programs written in high-level language can be compiled into a machine language, right? And so that we can we can have the computer understand the instructions. Okay, and the C++ programs look something like this, as you might have seen. I don't know if you have seen C++ programs or not, but this is an example of C++ program. It has a couple of lines of code. At the top, you have declaration, which is things like include and using namespace, which is standard, and the main function. So every program starts with a main function. Now, not every program starts with the main function. Okay, later on you'll learn that there are some programs that don't start with the main function. We'll get to that later. But right now, for now, your program's more than likely is going to start with the main function, and then it's going to have the instructions in curly braces. So this is the way you write code. These are the nuances of the language, the requirements of the language. As you can see, each line of code ends with a semicolon, right? So these are the rules of the language, right? So you have to learn the rules of the language, and you have to learn the syntax of the language as you go along. So what are the steps needed to process once you write a C++ program? What do you need? You need a source code. First, you need a text editor to write the source code. Then you need a preprocessor to process the source code. You need a compiler that compiles the source code according to the rules of the language, and then makes it compatible with the machine using the machine language. And then a program doesn't exist in isolation. It has different things like libraries and all of that. Libraries and that needs to be linked to your code. So that will be linked. Remember that at the top you might have libraries declared. That needs to be linked to your code. And then finally, the executable is loaded into the main memory, and then the program is now executed by the CPU. Now you can write a program using a text editor, and then get a preprocessor, and then get a compiler, and a linker, and a loader, and go and do all that yourself using different programs, and then create an executable and run the executable, and then test and debug your program. You can do all of that, but you can also use something called an IDE, or integrated development environment, to develop your programs. And it has an editor, it has a preprocessor, it has a compiler, it has a linker, it even has a loader. And it also produces an executable. So all you have to do is that output the executable and run the executable. Okay. And it has debugging tools. So IDE is a good it's a software that you can use to write code, okay, because it makes life easier. Some IDEs are what we call real time. That means as you're typing, it executes. I mean, go figure that, right? Making us more lazy. So that is also there. Especially Macintosh has Xcode that executes in real time. Okay, there are many other features of IDE, such as it gives you suggestions. It helps you find errors immediately before you write a lot of code, and it picks up your syntax errors, and it enforces rules of the language, and so on and so forth as you're typing code. So it saves a lot of headache down the road for you. So I recommend an IDE, and I recommend CodeBlocks as a good IDE. CodeBlocks can be used for many languages, but since it's written in C++, so it's native to C++, I highly recommend CodeBlocks. Okay, and to write your programs and test your programs. So, like I said, IDEs are very user friendly, and it makes development much faster for you. So here are the steps to processing a C++ program. As you can see, step 1, 2, 3, 4, 5, 6, execution, and if something doesn't work, you go back to the previous steps. So that's there. Here's a Here's a program analysis or coding execution cycle in detail, and it'll tell you what are the different steps in executing your code. Now, um, there are several steps to coding execution cycle. Number one is to analyze the problem. Look at the problem. Look at the problem. What is the problem? Remember, you are a programmer, not just knowledgeable in languages, because languages don't make a programmer. It's problem solving that makes a programmer. You know what I mean? So it's like a doctor. You don't become a doctor just by knowing what medicine to take for what symptoms. Anybody can do that. But the doctor is a problem solver. He looks at what the patient is going through, talks to the patient, and checks different things, different signs, and then solves the problem, get to the source of the problem using his expertise and knowledge. He's a problem solver. So all professionals are problem solvers, either doctors, lawyers, engineers, accountants, businessmen, or computer programmers. We are problem solvers. So we gotta look at the problem, analyze the problem, come up with a step-by-step solution called algorithm to solve that problem, and then use a computer language to help the computer solve the problem for us. Okay, so the language and the computer are tools. It's tools for you to solve the problem. So you are the expert, right, in problem solving. So learn problem solving. Now, computer language and mathematics is probably the best way of learning to solve problems, in my opinion. If you learn how to do mathematics and solve problems using mathematics, and if you learn how to use computers to solve problems, you're going to be a good expert in anything. Physics, chemistry, biology, engineering, computer science, computer engineering, whatever it is that you want to do, you'll be really good at that. Okay. So algorithm design is a skill that you need to acquire and be patient with. That's why I tell you, when you see a problem, a computer problem, don't sit down in front of the computer and start writing code. That is not the way to do it. At the beginning, if you get into good habits of looking at the problem, thinking about the solution, writing some steps down on a piece of paper, and then going to the computer and writing, make that a habit, because at the beginning, the problems are going to be simple and you can simply go to the IDE, like code blocks, and start writing code. That is going to be possible because, first 10 chapters of the book, they're pretty easy. I do that in half a semester in my mobile app class. We do arrays and structs and everything in about 6 weeks or so. So, but here I'm taking it slowly, step by step, so that you can be not just familiar with the language, but also get familiarized with problem solving by writing code, by solving lots of problems at the end of each chapter. Especially chapter 2 and 3 has lots of exercises. You should attempt to do all of those exercises, okay? Not just the ones that I assigned. Because I'll be assigning problems for you to do. Okay, so when you write code, make sure that there is no errors. You need to get rid of the errors by making changes to your code. Okay, so let's look at the example. This is an example from the book. Write an algorithm or design an algorithm to find the perimeter and area of a rectangle. So perimeter is 2 times length plus width, and area is less length times. This is a very simple algorithm. You're not going to see this kind of algorithms or problems in the real world. They're much more complicated. That requires, pages and pages of steps. But here, since we're taking baby steps, you might be thinking, this is just easy, just like common sense. No, you need to get used to this common sense. right? And then get into the discipline of writing algorithms before you write code. Okay, so here it is an algorithm. Get the length of the rectangle, get the width of the rectangle, find the perimeter using the formula, and find the area with this equation. And there might be some input and output that you need to consider also. Okay, that's part of your algorithm. So where the input coming from? Is the user going to enter, or is it coming from a file? Where the output is going to go, to the printer or onto the screen? So you need to think of all of those things step by step, right? That's an algorithm. Here's another example in the book. Example 1-5, calculate the student's grade, and it's asking you to design an algorithm. So here's an example of an algorithm, right? Get the 5 scores, add the 5 scores, and take the average. Okay. So here's the processing algorithm, the heart of the program. Remember, once you have a good algorithm, converting that algorithm into a code is easy. It's not that hard. So there are people that make big bucks writing algorithms. Okay, and then they give that algorithm to the programmer, and the programmer codes it. And then he makes less money. He's the one writing the program, right? He's the knowledgeable about the language, right? But he makes less money because the guy who writes algorithms, makes more money. Why? Because he's a critical thinker and problem solver. Okay, without algorithm, you cannot write code. Okay, so these are some of the examples in the book that you can look over. I'm not going to go over that. Like I said, there are 2 programming methodologies: structured programming and object-oriented programming. In our course, we're going to learn structured programming, the easy side, the old way of writing programs, because we're learning. And then after this semester, next semester, we're going to go into object-oriented programming, okay? Which starts, I believe, in chapter 10 of the textbook. And remember, the textbook that you have, the MindTap, it is going to be useful to you throughout your computer science journey, okay? So, if you want to purchase MindTap for a year, go ahead, because you're going to be needing it, all right? If you take programming 2 next semester, then you're going to be using MindTap also. Same thing, so you don't have to pay twice. So just get it for a year, and you can even renew it after 6 months. If you got it for 4 months or 6 months, you can renew it and extend it and have access to it as you go through it. Okay, so structured programming is a top-down approach, and it's a modular approach to programming. For many years and years, people have done structured programming using structured programming languages such as Pascal, COBOL, C, but C++ introduced the object-oriented, which is the latest way of writing code. Okay, even now we're moving away from object-oriented programming into protocol-oriented programming that you will be learning later on. Okay, the object-oriented programming is about writing objects, and objects contains the data and the operations into one single unit called an object, and the combination of objects or objects combined will be in a particular class. So all the objects, all the data, and all the operations is into one module, if you want to call it, and that would be a class. So you create class, you learn to create classes in object-oriented programming, which is at the heart of object-oriented programming, or classes. Okay, so I'm not going to go into the details of the history of C and C++. You can read that on your own in the book, as well as in MindTap. So here's a quick review. We'll learn about computer systems. We learn about algorithms. We learn about problem solving. We learned about structured design and object-oriented design.